continuing now.
Hello, everybody. My name is David Blanco. I'm the Director of Technical Operations and Business Development here at Automation Solutions. And today I'm going to be doing a 1-hour webinar on updates we have recently made to our product called Edge ACM. So real quick, here is our agenda for today. First, for those of you who may be joining us for the first time and maybe are not sure exactly what eACM does, I will give everyone a very quick refresher on what is eACM, how is it deployed, and when deployed, what does it do. Then we'll take a look at new features, and then I will also go over 2 new applications that we have that are going to help you work with and then also have more connectivity with Edge ACM when it's deployed, and that is AUTOSOL App Manager and AUTOSOL Bridge. Then I'll go into a live demo of some of the new features that I discussed earlier. Then I will do a very quick roadmap of where Edge ACM, AUTOSOL App Manager, and AUTOSOL Bridge are going. And then I'll take some questions from the audience. So just a quick reminder, if you click the chat icon here in Teams, in the top right there, that's where you'll be able to submit questions that I will be able to see at the end of the presentation, or even during, but once I get out of full screen mode of the PowerPoint here. So real fast, for those of you just now joining us for the first time, what is eACM? This is the big picture. This is the 10,000-foot view of how it works. So going from left to right, from field to server, you have an RTU or PLC out there in the field. Then you have some sort of IoT device. This could be built into your wireless communications, like into a cell modem or a radio, but in a lot of our deployments, we don't want to disrupt existing infrastructure, so it is a piece of equipment that we are deploying amongst the infrastructure here that acts as our Linux environment to run the Edge ACM app. Edge ACM, once deployed, polls the end RTU or PLC in its native protocol, and then can convert that into MQTT or MQTT Sparkplug B and pass it up the network to a broker where it can then be subscribed to by MQTT clients like NHMI, historians like Pi, and analytics. This can be on a server or in a cloud. But I'm going to go into more detail real fast on this functionality as well, and we'll start again from left to right, and we'll dive a little more into the field side. So Edge ACM can pull multiple devices simultaneously and multiple protocols simultaneously. So in this case, we're polling one of each of the protocols that eACM can handle. And the question will often come up of, well, how much can I poll? Basically, when we roll out a new version like eACM 2.0, our QA testing is basically we put 5 devices on it. Each device gets 5,000 tags. There is a 100% change rate in the value of those tags. So every time we poll with MQTT's report by exception, we're sending all of those tags up. Sorry, I forgot to put my alarm on there. And we're polling them every 5 seconds. So our QA is basically 5 devices, 25,000 tags, 5-second poll rate. So there's no software limit to how many devices or tags you can poll in the field. That's going to be determined by the network it's deployed behind, as well as the hardware device it is deployed on. And that's just for our baseline testing. So here are all of the real-time protocols that eACM currently supports: ROC, ROC+, so Flowboss, a variety of other Emerson protocols as well. Modbus, but again, there's no such thing as just Modbus. So there's, of course, ASCII, RTU, TCP. We have some built-in extensions to help the ease of deployment, as well as the ability to make your own custom Modbus register set. We also have ABB Total Flows, as well as Allen Bradley ControlLogic's CIP. So that's the field side, right? And eACM is basically going to be polling these end devices all at once, converting them from the native protocol to MQTT and sending them up. And of course, you can mix and match. One of the white papers we have out, we've got 2 ControlLogics and 3 ROCs for each site. And those are, of course, setting it back up to a clear SCADA system. So if we go to the server side here, eACM can also now support multiple broker connections. So you can send it to 1, 2, 3, 4, 5, however many brokers you want, and they can be in different places. One broker can be a local broker on site, another broker can be in the cloud, it can be an Azure broker, or you can have it back on your main SCADA server. You can mix and match the deployment. And we also work with a variety of brokers, so you can mix and match what works best for your organization. So I will be using a broker called Mosquito for the duration of this demo, but we also work with other prominent ones such as the Solace broker, Chariot, as well as HiveMQ. So they can be integrated into your existing processes as well. And if you already have a broker of your choice, eACM can be added to that process without forcing you to get a whole new broker. Now, eACM also integrates out of the box with HMIs that are likely already being used by you. For example, the latest release of GeoSCADA can now take MQTT data. Signet can also take MQTT data from Edge ACM, as well as, of course, Ignition. And, oh, I wonder where my other one is. Wonderware can also take MQTT data. So eACM can be dropped into your existing system and allow you to reap the benefits of the software without forcing you to redo any of your existing telemetry or re-engineer your HMI. eACM also has the ability to do backfill after communication failure. And for the sake of this conversation, I will divide those 4 different triggers thusly. Basically, if the field device loses connection to the server or cloud, or it detects that the broker went down, or if you set up something called a primary host ID onto one of the MQTT clients. So for this example, I'll pretend this HMI is my primary ID I want to watch out for. eACM can detect if the broker lost connection to that HMI or if the HMI itself went offline. If any of those 4 conditions are met, eACM is going to continue to poll the RT or PLC as if it still had the connection, but it will store that data locally instead of sending it over the network, waiting for any of these connections to clear out. Once they clear out, either the connection is made back to the server or cloud, the broker's back online, the broker can talk to the HMI, or the HMI comes back online. eACM then sends up that data to the broker where it's distributed to all the MQTT clients waiting for it. Now there's a fun metric I made here to answer the question of, well, how much can I backfill? Again, this is dependent on the hardware, but assuming you have a 1 GB of memory available to eACM to backfill, and you're polling 150 tags, that's polling once a second, and that tag is going to change every second, so it would be a published in MQTT, then you can get 23.5 days of backfill from that. And you can mix and match this metric as well. eACM does not save every tag by default. You get to select what tags you want. So if you only really care about 10 tags on a 2,200 tag rock you have, then you can just save those 10 tags. You can also break up these messages when you send them up, but I'll get into that later during the demo. So here are all the ways that eACM delivers both data and value to the systems in which it is already deployed. First and foremost, it reduces bandwidth consumption. This is done from its deployment of MQTT. What that then allows us to do is deliver higher resolution data for the tags that matter most to your operations, as well as backfilling that critical data up to your SCADA system, so that way there's no gaps, not only for operational safety, but also for EPA auditing purposes. We also integrate with existing telemetry. eACM has a built-in app called Priority Forward that can basically act as a quality of service check between eACM and any other service that needs to connect to a serial device, meaning that eACM can be deployed in front of serial devices without monopolizing that connection. You also do not have to replace or rip out existing field equipment with eACM. If you already have an IoT-ready piece of hardware in the field, eACM can run on that, so long as it's some form of Debian Linux. But you can also just drop rather economically priced pieces of hardware into your existing telemetry to get eACM out there in the field. eACM also integrates with existing SCADA systems, either one through natural MQTT drivers in that HMI, or from a product I will introduce shortly called AUTOSOL Bridge. So to use eACM, you don't have to re-engineer any parts of your HMI. So real fast, for those of you who may just now be hearing about MQTT for the first time, basically here's how MQTT operates. I have a radio here running eACM that's going to pull this RTU once a second to get this pressure. But every time I pull, I'm not publishing that data over the network. I only publish when there's a change. So here I just got a change. Now I will consume bandwidth and send this up to the SCADA system. Just with that feature alone, I'm able to significantly reduce bandwidth consumption. This is a test between Modbus, which is the blue bars, and MQTT, which are, if you want to call that a bar, the gray bars or the gray steps. Basically, with a 50% change rate, that means 50% of all the tags, their values changing every time I poll it. MQTT will save up to 84.73% of bandwidth consumption compared to Modbus. And if I expand this out to another protocol like ROC, MQTT will deliver a 57.89% reduction in bandwidth consumption. Polling the same points, just now you're going to use 57.89% less bandwidth. And that kind of opens it up for the other benefits, the ability to get higher resolution data. So here is a plunger lift trend chart of 24 hours from one of our clients. We have a white paper on this as well on our website. It is the Flywheel white paper, and they're monitoring a plunger lift here. So this is traditional polling before eACM was put in the field. This is off of ROC. We have 2,200 tags and a 1 hour poll rate. So we've clearly captured some flow changes, but we've missed every plunger step. Apparently tubing and casing and static pressure have not also changed despite the flow rate change. And after the client deployed eACM, this is what that same trend looked like. So now we actually have actionable data, and we were able to take them from basically a 1 hour poll rate to a 1 minute poll rate. So 60 times the data on the exact same network they were on. They were using a 900 megahertz radio network. We were just installed behind the radio, or on the radio, I think in this case, and we were able to get them higher resolution data straight up to their HMI, no re-engineering required. Now, eACM is a piece of software, and AUTOSOL is not a hardware company, so there are a number of pieces of hardware that eACM does run on, and they are these. First, in no particular order, is the MOXA, and there's a variety of MOXAs that we run on: UC8100, UC8200, B2201, 3100. If it is on the MOXA's IoT page and has a Debian Linux environment, we run on that box. ZetaWave also has two products, Zeta Edge, and then I believe a line of their radios that has a built-in Debian environment that eACM can also run in. FreeWave has the same kind of setup. They have a radio and a non-radio, like an industrialized smart switch pictured here, that can also run eACM. And both the ZetaWave and the FreeWave smart switches there can just kind of be, any of these can be dropped behind existing infrastructure and then run eACM. Lenovo also has a IoT device that we are running on, as well as, dare I say it, a Raspberry Pi. Not every site is Class 1 Div 2, and without getting into the fallout from the Rona that we're all familiar with, if it works, it works. So I'm going to start looking at some of the new, the new look and features of eACM. So this is a quick snapshot of what we see later. Basically, we re-architected the software to give it new abilities and a new look. So here are some of the new features that I will briefly explain and then demonstrate. First off, on the back end, we have a new architecture that allows eACM to present data locally on the edge device without having to use MQTT. So now I'll call them third-party applications can receive the data that eACM is gathering from the end devices and then process it. eACM can then read that data back and publish it. On the MQTT side, we added the ability to nominate a primary host ID, which lets us detect, again, a client behind the broker that if he goes off, if we have one primary host ID and 1,000 other clients, but that one primary host ID goes offline, eACM will go into backfill mode to make sure that that important client gets it. We can also do MQTT TLS because we have, believe it or not, have had several conversations with y'all's IT departments, and we'll do what they tell us to do. You can also backfill to disk, which means that if eACM is cut off from the server or any of those other conditions, and it is backfilling data and there's a power loss and then it comes back on, you don't lose that data. So you can save your backfill data to the local disk, If there's an SD card slot, you can save it there. And then let's say you have a device that is polling, one tag for every second, and it's offline for a day. Well, now you've got tens of thousands of values to bring back. And if that's a 900 megahertz radio or a serial radio network, and you don't want it to clog the network, you can actually control not only how many values you put in each backfill message, but the time between each backfill message is then sent. So you have control of what you backfill and how you send it up to the network as well, down to the millisecond. And I'll show you that shortly. And again, I also mentioned that we have the ability now to connect to multiple brokers simultaneously. On the polling and protocol side, we've gotten a lot of feedback from operators that they like MQTT's high resolution data, but miss the ability to spam the demand button. So we added a demand capability into our MQTT package, and I will demonstrate that. So now if a operator gets nervous that they haven't seen data update in a while, they can hit demand and then get an update to that value. And that's also what the rebirth command does as well. Basically, send me all of the values off this device now. You can also break up on eACM tag groups and assign unique schedules to each tag group. And that is where a big savings of bandwidth and the ability to get high resolution data is really going to come into play. And I'll demonstrate this. But before I move on, let's say I've got those 2,200 tags from the flywheel example earlier. I could put 1,995 tags in one group and poll them once an hour. Then I could put 5 of those plunger lift tags in another group and poll them every minute, every second. And what will happen then is my publish rate on eACM can be 1 second. So I'll still poll kind of, the important but not important enough to poll every second tags. I'll poll them once an hour and still get them via MQTT. But I can really hone in on these 5 tags. So now I'm only sending 5 tags worth of data every second or every minute. So I can get high resolution data for those tags that matter most and not have to burden the network with these other 1,995 tags that are probably largely going to be static, like valve statuses or GC states, things like that, or configuration tags off the rock. We also have the ability to write custom Modbus register sets. And we also have Azure IoT Hub connection, which I will demonstrate if I have time. Now, I mentioned we have another application that facilitates the deployment of Edge ACM, and that is currently called Universal App Manager. This is not the marketing approved name, but after consultations with that department, I believe this will change to AUTOSOL App Manager. But for the purposes of this demo, and because this is the name that appears in the software, this is what I'm going to call it. This is how the architecture we've already seen works with Universal App Manager up here in the corner deployed. Universal App Manager is how you manage from a server or cloud side all of your deployed eACMs. So eACM is fun to work with on the box for the first 5, 50, 60, 88, 100. That's when it kind of starts to become a more difficult task of logging into every box and trying to change configuration if you have to, things like that. So UAM sits on the server and lets you communicate to all of your deployed eACMs and change their configurations, update licensing, import, export templates, and I'll demonstrate all of this as well. But the reason that I think this has a lot of value is that Universal App Manager can automatically detect deployed eACMs. So long as the eACM and the Universal App Manager are both on the same broker, Universal App Manager can automatically detect the eACM, download its configuration, and sync configuration. And I will demonstrate all this shortly. Now, the communication between UAM and eACM is done via MQTT. One, to reduce bandwidth consumption, especially if a client has, middle of nowhere 900 megahertz radio networks or 400 megahertz radio networks. We don't want configuration to be why something loses connection, but you can also compress that MQTT message further, and I will demonstrate both of these features. UAM will also be able to host server-side applications that we or you create. So, for example, I have some roadmap items on features we're adding into Universal App Manager. The other application we have is called AUTOSOL Bridge. And this is what we saw earlier about eACM's ability to connect to HMIs, right? I've got Geoscada, Signet, Ignition, Wonderware. Now I know that Signet 7.2 and up has an MQTT driver, and you may ask yourself, well, if these HMIs can already talk MQTT, then why do I need the bridge? Basically, what the bridge does is it is going to subscribe to the broker and receive all of the MQTT aliases or tags that are coming off that broker. It will then convert them into OPCDA for HMIs that require OPCDA to then consume. So, for example, yes, the latest version of Signet and ClearSCADA/Geoscada have the ability to consume MQTT data, but what if a couple of things are in your way, right? What if it's too costly time-wise or monetarily wise to update? You don't want to have to re-engineer your SCADA network, right? Because you've already got history on these points. You've got reports and screens and all this stuff built around these tags you already have. AUTOSOL Bridge means that you don't have to change anything in your HMI. You just point to AUTOSOL Bridge as your OPCDA server, and now you're receiving MQTT data from eACM as if it was OPCDA data. And I will demonstrate that as well. So here we are at the demonstration portion. So here is a lookout of what I have on my desk right now. So working from left to right, I've got a Modbus. Sorry, I have a Raspberry Pi running a Modbus RTU simulation. So I'm going to focus a lot on tags 40,001 and up. I have a box that I won't name who that is running Edge ACM. Edge ACM is converting that data into MQTT Sparkplug B, passing it up to a local Mosquito broker, where it is then being consumed by 3 clients. 1, Universal App Manager, 2, Ignition with its native MQTT driver, and then I've actually got a 2017 version of Geoscada that is going to be using the bridge to communicate. So without further ado, let me change what screen I'm sharing. All right. So hopefully the screen transitioned properly. I'm not getting texts from my handler saying that's not, so I will continue. And I'm gonna go ahead and open up a browser real fast. And this is basically me logging into one of my boxes, right? My device is 127.16.60.120. And basically this is the home screen. So this is the new architecture. I can very clearly see that I have more apps than I used to have. That's part of the backend stuff. Is we broke up the Polar Edge ACM from the publishing AUTOSOL MQTT. And if I go into Edge ACM here, I've got the 4 items that I need to actually communicate. I have a connection saying what IP address and port am I going to hit to actually talk to something. Once I'm talking to him, what language will I be speaking? For the purposes of this, I'm using a Modbus protocol object. I have a MQTT publish rate of 1,000 milliseconds. And I'm going to speak via Modbus TCP to Modbus RTU. I do not have a custom register set assigned. I'm just going to be speaking 40,001 and up. And you can see here I clearly have multiple tag groups selected. So if I go into a tag group here, let's go into up. So basically, these are 6 tags whose Modbus simulator is counting up from 0 to 99. And I've got the register, which is the actual value I'm pulling off of the end device, and I've got my alias. And there's a couple things here I'm going to go into first. First, I'm going to move this out of the way. And basically, on this tag group, you see that I have a schedule object. So these tag groups here, up, rights, downs, and aliases are all using, I guess not aliases, but these are all using the same shared 1,000 millisecond schedule. So these guys are all polling at 1 second. I've got a couple others here. Let me just clear all this real fast. I've got a couple others, like I believe demands, that is polling on a 60,000 millisecond one. So this is that ability I mentioned earlier for you to break up certain tags that maybe only have to be polled once a day, once an hour, once every 4 hours, versus the tags that you really want to get into, like tags on a tank battery or a compressor station that maybe the EPA has a certain fondness for auditing, or something about a river crossing pressure, things like that that you can really delve down into. And on these tag groups as well, let me go back down to up because I'm going to spend a lot of time in him. There's a number of ways to interact with this. This is not a new feature. I just wanted to show that it's still here. I can export this existing configuration to a CSV. And let's just say I'm just going to delete Mr. 40001 just for fun. I'm going to open up this CSV that I just exported. And basically now I have a way to templatize and import-export tag settings between Edge ACMs. So 40001 is here. So when I import this back, 40001 will come back. So we see he's missing. I will go ahead and choose that file. Import. And there we go. Mr. 40001 has returned to us. And there's a number of other settings, right? One, backfill is set to true for only him. So if my box loses connection, I only care about backfilling just this one tag for the purposes of this demo. I've got deadbands of percentage and absolute value that I'll go into much more detail shortly here. I just wanted to show off that feature while I was here. Another feature we added, of course, is you'll eventually get a bunch of tabs open, and as I move my mouse around two different tabs, I am highlighting there in the tree on the left which tab I'm in. And you might notice this little feature also from ACM. So these are the changes made to just, I guess, this area here. Not too many, but just some slight functional changes, right? There's a lot of changes made to the broker. So I've got 3 different publishers and brokers on this device. So let's look at some of the changes made to my publisher here. Pretty simple stuff. On the MQTT side, quality of service, of course. Sparkplug V, here's where I can set that primary host ID. I have made my primary host ID my ignition server, so I will sever it later on in the demo. For backfill, I can actually choose to do it to disk, and I can send it to a folder structure that I want to send it to. eACM will make one folder structure down from where the folders do not exist. So I've got this backfill folder here. I have elected to only allow 512 megabytes of space to this. And if I wanted to, if I was not connected to something literally 6 inches from my laptop, I could split my backfill messages by number of values per message. And then on this one, I can actually say what to delay each one of those backfill messages by. So for my purposes, I have it set to 10 seconds, but I'm not breaking up my messages, so it's not going to affect the demo. And of course, let's see here. Yeah, that's all for that. On the Mosquito broker itself, we added the ability for username, password, and of course, TLS as well, which I don't have selected for the purposes of this, but it is there. And you also may have noticed this here. Let me close that guy. We have the Azure publisher there as well, and priority forward. There have not been any changes made to priority forward. I just wanted to make note that my eACM is polling through this application. So that's it for this side. I'm going to go ahead and show some data actually coming in to talk about features like demand now. So here is a ClearSCADA system that I have that is polling these tags, right? 40,001 through 40,006. These Modbus tags are going up every second, 0 to 99. 26 through 31, these are going down between, I think, 0 to 100. These are just here so I can start sending writes shortly, and this is my demand demo. So let's hone in a little bit on Mr. 40,001 and talk about our deadbands and alarms and how those have been impacted by the demand. So basically here, 40,001, you see him tick up every second. My box is polling every second and publishing every second. And since the value is changing on my Modbus simulator every second, hence 40,001 changes every second here. 40,002 and 3, however, have percentage-based deadbands, and as do 27 and 28, but going the opposite direction. So these are 5 and 10% of current value, not of range of value. So you'll notice that they get out of sync, but they kind of loop back in because they're 5 and 10%. 40,004 and 40,005 are absolute value deadbands of 5 and 15, and 29 and 30 are the same, but the opposite direction. So 40,005 will update next at value 45 because that is a absolute value 15 change of 15. So basically eACM is polling every second. On the box right now it's 43, 44, but it's only going to publish it to 45 if it's in the deadband. Now 40,006 has quite a lot going on, so I'm going to kind of zoom in on him real fast and talk about him. He has a deadband of 10, but also 2 trigger points, right, of 90 and 10. So he will update by 10. So he'll update what, again, at 71. There we go. And then 81. And then when his value on the device hits 90, he's going to go into the high trigger state. This is not an alarm for legal purposes, but it basically will drop his deadband and he'll update every time he changes value, as we'll see now. And then when the tag loops down back to 0, he'll be in violation of his low trigger point. And that means that so long as the value is at or beneath 10, we will update every change of value. This is a homebrew Modbus simulator, by the way. So there we go, 9, 10, 11. And now that it's been 11, eACM in the box says, well, 11 is not more than, well, 1, 11 is outside of my trigger point. And 2, 11 is only 1, not 10 more than 10, so I'm going to wait until 20. So that's how that works. And before I move on to something else, I'm going to layer one more thing on top of this, and that basically is I'm going to go into the box here and I'm going to change my publish rate from 1 second to 10 seconds. There we go. And now what'll happen is once this guy hits, well, I guess 1, you notice that 40,001 kind of stopped ticking. He's ticking every 10 seconds now. That is because he's still polling every 1 second, but I'm publishing every 10 seconds. And when I publish every 10 seconds, I'm sending up 1 current value and 9 historic records to my HMI. So he'll update again at 76. There we go. So what'll happen when 40,006 is triggered again? 2 things. First, the entire device will change its publisher from 10 seconds down to 1 second. So you see, I'm getting a much higher resolution picture of my entire device right now because 40,006 is triggered. And even it happened again on the lower trigger. And 40,006 itself doesn't have its deadband active. So this is designed to give you the ability to give your operators higher resolution data during specific alarm events. If an ESD is triggered and you want the whole site to start polling at a higher resolution rate, then this is how you do it, right? I have my publish rate at 10,000 milliseconds, or 10 seconds. I have alter publish rate on points limits checked, and then my new publish rate is 1,000 milliseconds. So basically, if one tag on this device is in a trigger state, I want the whole device to publish faster, and I want that point's deadband to be dropped because I want to know exactly what's going on. And then once the condition clears, right, we're back to business as usual here. So I'm going to put him back down to 1 second for the purposes of the remainder of the demo because it always looks better when data is coming in. And then I'm going to show you Bridge. So this is not a version of Clear's data that supports MQTT. There is one, but this just isn't it. So how is this getting any data? Well, basically, if I go to this tag here, let's do Locate in Database Explorer. Here's this point. I open him up. He's an OPC tag. He's very clearly an OPC tag. And if I click this ellipse, these are all of the tags coming off of my eACM. So I've got the Bridge software in between my broker and my Clear's data. And my Clear's data is using Bridge as my OPC server. So again, I've got eACM publishing to my Mosquito broker. Yes, this is it. It's just a background service and it's easy to use, which is why I picked this one for the demo. And then I've got the Bridge service here that is looking at that broker. So this is the IP address of my laptop, 127.16.56.128, and I've got a good connection. The server's running, and then I've got clear data here. If I go to its server, it is looking at ASI.MQTT, which is how the bridge service presents itself. For those of you who use ACM for your OPC DA server for your HMI, ASI.OPC is ACM. Whew. But we're MQTT here, and I can see all of the different tags coming off of that bridge, as well as you see a demand tag. So if I am an operator, and let's look at this tag here, Mr. 40,007. If you recall, he was in his own tag group all by himself, and he has a poll rate of 60 seconds, which is why he only updates every 60 seconds. But my box is publishing every second. So if I hit demand, I'll get an update of his value. So I'll just keep hitting it. So now operators have the ability, one, to take advantage of the bandwidth savings and high resolution data from MQTT. So there's less congestion on your networks. You're getting data more reliably and more accurately and more of it. But now operators can still hit that button that they've come to know and love. And something I would also like to point out is if I do a demand, well, let me wait until it cycles to 20 real fast because I'll need 10 full seconds to talk. There we go. If I hit a demand, you'll notice that I'm actually going to update this tag as well as this tag, but he'll still update at 30. This is a out of band gathering of data. So all of your dead bands will still be there. Again, this is just so that way your operator feels good about this deployed technology. He still feels in control because he is. I can also send writes down. So let's just, for fun, send a write down to 51. I'm going to control him from 5. Let's just make him 1. And there we go. So that is what I had to show for ClearSCADA, right? ClearSCADA is getting data via the bridge. And if I was just looking at the HMI, there's almost no real difference in OPC to MQTT other than I'm able to get more data. So I'm going to show ignition working now as well. And basically, this is the same screen that we just saw, but in ignition. And this is what I was able to make after a couple hours of watching some training videos. So I apologize for how less fancy this screen is. Basically, we see the same thing here, right? 40,006, 4031. I've got my demand button here as well that I guess I need to enable read write on. Good thing I had that caveat before I clicked, everybody, huh? So here real fast, while I go find that, I can get just basically in ignition, right? Here are all of my tags that I've got coming off of that. And just for fun, let's click demand here, enable read write mode. There we go. Now let's go back to the screen. So I'll do my demand button and get the same satisfaction. And if I very quickly go over to ClearSCADA, we see that the demand value changed in both places, right? 32. And if I just hit it again, 43. So they're both reading off the same broker, so that makes sense. Something else that it was in one of the later 1 point whatever versions, but I want to bring your attention to it now is you're also able to do the traditional nested aliases here. So I've got a tag on my eACM, I believe it's in the alias tag, where basically you can flesh out the alias structure here for your tag, and this is how it ends up showing up. It's in this nested folder structure. So I'm going to quickly show you Universal App Manager. So let's just close both of these for now and go here. So I've got a web server. I've got a web server here running in the background. This is Universal App Manager. It is a background web server sitting on a Postgres database that is accessible through a browser. So if I go up here to my browser and I type in 127.0.0.1 port 8080, I am taken to a screen that looks an awful lot like Edge ACM, and that is because it is the exact same code running on my server now on this application that is running on Edge ACM. So it's one code base running in two places, which means that it's easier for us to maintain and therefore easier for us to add new features for you. So if I go to my app manager, I see Universal App Manager up here on the top, and let me try to get them, oops, there we go, decoupled from the snap-in. I've got Universal App Manager for the server side and Edge Manager for what is on the edge. And the really cool part about this, I'm going to put this down here so we can watch it communicate, is I mentioned the auto discovery. So my Edge Manager is, in theory, there we go, connected to a broker at 127.16.56.128. That is my laptop, which means it is connected to this beautiful Mosquito broker I have here. If I go to the Universal App Manager, I've got the same thing. He too is connected to a broker on localhost, my laptop, because that's where he's running. So if I was to right click here on the server, I can do a command and discover nodes. This is going to, again, discover all of the eACMs that are attached to that broker I have. And we see here I have a whopping 2. I don't have a very big desk. So I've got 2 devices connected there. And what we don't do is we don't upload all of the config for everything all at once. Heaven forbid it's new intern's first day and he is told to go in here and he hits sync and he gets 1,000 eACM device configurations all coming in at one time. So now that I've discovered this device here, I can come here and do sync. This is what actually goes and retrieves that data. And there we go. So I'm getting data. And it looks an awful lot like this. So if I open up Edge ACM, I've got the exact same, identical structures. So now for fun, I'm going to go into the Universal App Manager, which is just another browser. And I'm going to go into Raspberry Pi device, and I'm going to change my publish rate. 4444. Enter. So I save it. And then without hitting anything else, I'm going to go, there we go. I'm going to go to my Edge device, open him up, and that change was automatically sent. So now my Edge box and my server side config manager are syncing between each other. So if I want to make a change here on the Edge, right, let's just make him back to 1,000. Great. I'll go back to Universal App Manager. I do have to close and open the device, and he's back to 1,000. So that's part of the beauty of using MQTT to communicate between the server side and the Edge side. One, of course, reduce bandwidth, but 2, we make use of the report by exception feature of MQTT to catch changes and then automatically send them up or down. So real fast, I'm going to open up a client called MQTT FX. It is going to let us watch the raw, okay, not Microsoft Edge. Could try Microsoft. We are not sponsored by them. MQTT FX. Let me, I guess, click it. Sorry, first time ever using a computer, everybody. And this is basically going to let me see the raw values coming off of my Edge ACM. There we go. So I'm going to connect to my local broker. I'm going to subscribe to him. And then I'm going to go ahead and make a change. So let's change him back to 4444. Go to MQTT-FX, stop the auto scroll, and I see here 2 messages. Node. Right here, this is the message that UAM is sending down to the Edge device. And this is human readable. And here we see my change, 444. If I go to the Edge device and I, close him and open him back up, I see 444. I'm going to change him back to 1,000. And there we go. We see this manager call. This is the change eACM sent up to UAM, which is not readable. That is because what I sent down was not compressed, and I can see that here. Sorry, this is the Edge. So on the Edge device, I am compressing messages up, which is why this guy is not human readable. It is compressed MQTT. If I go to the server application and I go to him, we see that he is not compressed, which is why his message was human readable. I just wanted to do that to demonstrate exactly what that meant, is basically a reduction in bandwidth consumption during this configuration period. The last thing I'll do before I will go to the roadmap and then start taking questions is I'm going to just cause a little bit of havoc here. I'm going to delete everything off of my end device. Which is generally a good sign that you know that I am actually serious about coming to the end here. So I guess I'll also stop all these processes too. So let's pretend that I just got this box. This is a brand new box, and I've done nothing on it. I could go to my Universal App Manager, and let's just do here, and let's resync it to really get into the fantasy here. There we go. Everything's dead. So this is a brand new box. Lightning struck because that's the only way that eACM is going to stop working. And you have to send a technician out there to put a new box out. Oh, sorry, I just noticed I tilted my camera. So I can come here and I can actually do an import of a template that I had made earlier. Luckily for y'all, I had, and I called it David's demo so I wouldn't forget it. And if I open him up and bring him in, I basically am going to import all of the settings that I just had. And I'm doing this from the server side. This also works on the Edge side. I just had to show it somewhere. So now if I go to Edge ACM, I've got all these objects. And I can go here and I can, oh yeah, I guess I have to sync it first, don't I? And if I want to start this process, I want to start this process. This is an easy way to do basically templatized import exports of configurations while you're rolling out new boxes or what have you. And so now I'm getting my alarm for time here. So I will go ahead and go onto the roadmap very quickly and then start to field questions. So let's bring up, there are animations for this, but I'm not going to change screens again. Basically the roadmap. So this is a good opportunity for me to mention that there is a change coming to ACM relevant to MQTT. And that is that we are adding a service to ACM called ASI Bridge. ASI Bridge is AUTOSOL Bridge. So this is a way for ACM to subscribe to a broker and then get all of the tags coming off that broker and publish them OPCDA. So this is, again, ACM basically incorporating this bridge functionality into itself. Now, eACM does not require ACM. eACM does not require Bridge. eACM does not require Universal App Manager. eACM is a standalone application that is designed to go into your existing telemetry and integrate with your existing SCADA software. But the other products just made the experience much smoother. So this enhancement to ACM is something that can be used in conjunction with eACM or independent. If you have another MQTT SparkPlug-B publisher Edge device, ACM can now take data from that. So look out for this update coming at the end of this year. Please call your local account manager or salesman. Now for eACM itself, we are adding the ability to collect EFM data. I'm calling it eEFM data, and no, marketing did not pass on that, so the name will change. And here's what that's going to look like. Basically, it's the architecture we saw before, where eACM is deployed to the field. And not only is eACM pulling the real-time data here, but it can also then collect the EFM data the same way ACM does, with the difference being eACM will then collect the EFM data on the edge, and then it will push it via MQTT SparkPlug-B via a payload that we are creating currently to a broker, where ACM, with its latest ability to subscribe to a broker, will then take that data received from eACM, take that EFM data, put it into the SQL database that ACM already sits on top of, where it will be saved. So you can continue to use ACM for your publishing to FlowCal, PGAS, TFX, CFX files, whatever it is you currently use ACM for. That will not change. All that will change is you now have the option to use Edge ACM to go collect EFM and real-time data and use MQTT. ACM could still continue to publish data to your HMI via OPC, and that is our plan going forward. So I mentioned this, wanted to let you know that we're working on it. The first protocol that we hope to have released with eACM capability, Edge EFM collection capability, is Emerson products. And we will have a beta for that available hopefully at the end of January 2021 is our current goal. So if you would like more information about that, I will show my contact information at the end. Contact your salesman, contact me, and I'll be happy to have a meeting or conversation about it to not only tell you where we're taking it, but also solicitate your feedback. So apart from adding EFM, which is a huge undertaking for us, we're also adding the ability for automatic tag discovery for the control objects protocol, and also adding security. Again, we have also sat in on meetings with your IT departments and are adding things like username and password and HTTPS to the local browser access for Edge ACM. For Universal App Manager, which again was the server-side application that lets you manage deployed Edge ACMs, we are adding the ability to host Bridge into it. So this standalone UI of Bridge will be merged into the Universal App Manager structure and will be a server application that will appear here as well. UAM will also act as a repository for install files. Many of y'all have test labs or staging labs that have no internet access, and for good reason. So if you have UAM on your SCADA network and you're going to get 500 eACMs deployed out there, you can now unbox the device, plug it into your test lab, and then have that box ping Universal App Manager, and Universal App Manager will install Edge ACM on that device without needing any sort of outside internet connection and without forcing you to manually drag and drop files. UAM will also act as a licensing server. So you, in the future, hopefully by the end of Q2 next year, you'll be able to license Universal App Manager for 500 devices and then push those down to Edge ACMs, Edge eACMs, I should say. And this is kind of what that looks like with UAM managing the bridge, right? It's basically also going to happen via MQTT, but just locally on that same server. So without further ado, I will go ahead and take questions. And while I take questions, I'm going to try to have this up. So that way, if you want to contact me or don't feel like I answered the question sufficient enough, you can feel free to call, ask for David Blanco. You can also, of course, just email me directly, dblanco@autosoln.com. To get the white papers, please visit our website, autosoln.com, and they'll both be available there. So let's see here. I've got some questions. This is from Anonymous. For example, using radios, can we do MQTT gathering every 0.5 seconds and grabbing the data every 30 seconds or 1 minute to save power used by the radio? The answer to that question is yes, you can. Let me check this guy. Okay, so I am polling here. So if I go to the Edge device, let me just refresh him since, remember I deleted everything and then I added everything back. You can change your poll and your publish rate. So if I'm going to poll in your example every half a second, I won't do it here because my Modbus simulator is made by me and it's not that good. It only updates every second. So if I come here and I do, if I change my publish rate to 10 seconds, but my poll rate still 1, what we'll see is, and I'll show you here in Ignition, this guy is going to flatten out, but every 10 seconds, I'm going to get a package of 9 values, 1 current value and 9 historic records. So after 10 long seconds of dead air in a demo, there we go. So this guy just updated with all 10 of those values. So the answer to your question is yes, you can gather faster than you publish, and when you publish, you're going to send it bundled in with this message. And just to really beat this horse pretty much into glue. If I go to my HMI here that we just saw, and I go into, oh yes, log in. Okay, no, keep the passwords. I go into logs, we'll actually see this backfill happening here. So here is 9 historic records that were sent in. And basically, that's the answer to the question. The answer to the question is yes. So, and we just see it again. So next question. Oh, okay, liking doesn't actually move it. If we don't have Linux expertise, do you provide guidance in documents or install guides? Yes, we do. We have a number of, I believe, public-facing guides that teach you how to install on the boxes. Like, for example, to set time for the box, this is my touchstone. So we tell you how to install the files and what's going to be required. Like, for example, currently, if it's not wrapped up in a PKG file, an internet connection is required to download the Python dependencies. But that's why Universal App Manager is the future repository. And not to speak out of turn for the developers on my team listening to me, that feature is actually already added. It is just not merged into the main branch and released yet. So we have that capability, and we will be releasing it, I believe, before the end of the year. So the answer to your question is yes. We have basically how to install Postgres databases. We have all of that documented. And of course, if you do have a device, feel free to call us, and we're happy to also walk you through that process. The next question is, how long can eACM store the data locally? That is a function of what piece of hardware you have. So eACM, by default, will save it to memory if you do not allocate a hard drive space or a SD card slot to save it to. So if you have 1 GB of memory and you're polling 150 tags every second, and they're changing every second, so you're going to save them every second during a backfill, that gives you 23.5 days of data. What happens at 23.51 days of backfill? We start deleting the oldest records and replacing it with the newest records, is what happens. So how much you can backfill depends on how much space is on your box and how many tags you have set backfill to true for. So if you're pulling 2,200 tags and you hit backfill, you probably have more than a week, because all 2,200 of those tags are probably not changing value. Your vals probably are not changing value every time they pull, or your GCs are probably not changing value. So I hope I answered that question. Can you comment if BSAP protocol is supported too? BSAP is not currently supported. Right now, a lot of development effort is going into our eACM, right? The eACM collection from the Edge. BSAP is on, the, I'll say, roadmap for future protocol development. But before I can collectively hear the eye roll of all the developers hear me say that, I will differentiate between roadmap and schedule. Schedule is something that we have on our schedule with a planned release time and developer on it. And roadmap is, yeah, we would like to do it. So a good analogy is, I'm in Houston, Texas. If I'm going to drive to LA, but I make it to El Paso, and then I have to go up to Denver, well, LA is still on the schedule, on the roadmap, but not on the schedule now, because I don't know when I'm going to get there. But yes, short answer to your question, is BSAP supported? Not now, but in the future, we plan to. Any difference between eACM and Ignition Edge? Yes, several. I don't believe Ignition Edge, for example, has quality sent up with it. When we send up our tags, we do quality. We are also probably more economical. We can support more devices. We can support more tags. We have a larger variety of industry relevant protocols. Our EFM modules are going to be based off the tried and true success we've had in ACM, so you get the same level of quality there. It's not an experimental batch you're buying into. You don't have to have Ignition on your server to run our Edge software. Our Edge software runs with any compatible MQTT subscriber, so it frees up it frees up your Edge from having to rely on the same menu you are for your HMI. So hopefully that wasn't too. Hopefully I didn't sound too happy while saying all that. But yes, really the best way to find out is to contact me. I'll be happy to give you a demo of it, and we can go head to head. Can eACM collect measurement data, archive data, then provide a CFX file? The answer to that is no, but here's why. eACM will collect the data, send it via MQTT to an ACM on the server. So for EFM, you got to use ACM because there is not a public standard for EFM collection over MQTT. We are creating that public standard currently. So basically, eACM collects EFM data, sends it to ACM. ACM gathers it, puts it in a SQL database, and from there you can then provide a CFX file. Yes. Is this so? The next question is eACM speaking Sparkplug-B spec of MQTT? Yes, it is. It also speaks normal MQTT, but there's not a standard for that. So if we don't have the custom JSON configuration of that brand of MQTT, contact us. But otherwise, we prefer Sparkplug-B because it is standardized. That's why we work out of the box with Ignition and Signet and ClearSCADA and Pi and Azure, which I didn't have time to get to. So I am, speaking of time, I am at 12:01. So I will actually, until someone comes into my window and tells me to stop, I will keep going. But I, of course, free all of you. If you do have a lunch date or something like that you need to maintain, please feel free to leave. I will post my contact information here, but I do want to keep answering questions. So I only have about 4 or 5 more, so I will keep going. But if you need to go, I understand. Thank you very much for your time. Please do not hesitate to reach out to me, your salesman, or any other member of the AUTOSOL team. We're happy to help. So real quick, can I talk about Docker support and also how licensing would be handled? On Docker, that's kind of, I guess, we would love to dance to Docker's tune, but the trouble is there's nobody else at the ball who wants to dance with us on that. Currently, no edge devices that our clients have approached us with support Docker or is a requirement. So if you know, Mr. Tier 1 big oil man came to us and said, David, I love eACM, but it has to be on Docker before I can deploy it, that's a conversation I would very gladly have. But currently, no one has required it. And I, just off the top of my head, from everything I know about the industry and with the part that we're in, it's also not on the schedule, just because no one has made it a requirement for deployment for us. How licensing would be handled? If that is a question for within Docker, how would licensing be handled? I don't know, because we don't have Docker yet. But currently, licensing is handled for each device. Basically, if we go here to the screen again, and I go to my Edge ACM properties, this is where I put my license file. So I have a perpetual, never-ending file for 10 device connections. See, the next question here is, you can now gather data across serial networks. How does the client at the end tell the broker at the end tells Signet or FlowCal T drop the port and allow then in? Okay, so that is with a application called Priority Forward. And basically the way that Priority Forward works is here. This is I hate to say it like this, but it's basically a quality of service application or a traffic cop. And what it does here is, so this 60.69, that is the IP address of my Raspberry Pi. And I actually have a slide here. Let's see if I was prescient enough to put it in supplementals. No, I wasn't. So I'm going to open up another presentation that I do have a slide for it in and just explain this process real fast. Here we go. So slideshow from current slide. Oh, and brilliant! It's on a different screen. But basically, let me stop this. Basically, the way that Priority Forward works is I've got eACM talking to an end device, and the end device is serial, right? Sorry, I'm getting ahead of myself here. This is what happens when I go off script. This is the Priority Forward application, and what it's doing here is it is actually handling the communication to the end device. It's acting as a buffer. It is then presenting 2 ports on this device, 60.120, 40,001 and 40,002. 40,001 is the priority port. What that means is if any traffic, any EFM traffic, configuration traffic, David, the intern's first day, accidentally tries to log into the device on this port, any traffic is going to shut off access to everything that is polling through port 40,002. I happen to have eACM polling through port 40,002. If you go to my connection, I see I am polling internally on port 40,002, and that is because I am hitting that priority forward. So if any connection, anything, hits 40,001, what happens is eACM's communication is suspended. It pauses the polling. It allows the other application to then talk to the serial device. And then once that other device releases a connection, there's a timeout period, I have 5 seconds here, where eACM can then resume polling. So that is how we handle the serial device. eACM can be polling real-time data to a serial device, bop, 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 once a second. EFM collection from ACM, from Signet, can come through, hit priority forward 40,001, that will automatically stop eACM, let that through, gather the EFM data for as long as it's maintaining connection. Once the connection is released, eACM kicks back up. All of this is logged. So if I go to my priority forward log, it would all be logged, all the different connections. So here, apparently, the last time I played with it was, oh, I'm pulling through it now. But see, secondary connection is closed. So every time eACM gets interrupted, it's going to close the connection, log it. So that way, if someone says, well, I thought eACM was polling, why do I have this gap in my data? You can go and see, someone logged in to the priority forward app or through the priority forward app and was talking to a serial device blocking eACM. This is an automated process designed to stop someone from having to know the IP address, log in, stop eACM, use the configuration software, gather EFM data, then remember to go put everything back on, right? The fewer times someone has to manually interact with something that was set, the more we can forget it and the more it can run successfully. So that's an automated way that we handle that process. Is broker redundancy supported? In the idea of it being, I have a broker 1, broker 2, yes. In the idea of this is my primary broker, only activate secondary broker if primary goes off. Not in the released version, I have no, but in an unreleased version, we have cooking yes. So short answer, no. Does UAM allow you to update your certs? Does it monitor when a cert is going to expire? If by certificate you mean like a TLS certification, without remembering the answer of the developer during his presentation of what he was working on for security, I'm going to shoot from the hip and say yes, because it's all the same code base in eACM and UAM. So if it is a configuration setting you can set on the device, it will be a configuration setting you set in UAM. So the answer right now on record will be yes. UAM will be able to change out certificates on deployed devices. Do you have a AUTOSOL Bridge in OPC UA on the roadmap? Do I have an AUTOSOL Bridge in OPC UA? Yes. Yes. ACM's UA ability is scheduled for release this January. It's going to be a very busy Christmas. We're actually we actually have some of Santa's better elves interning with us during that time period to help meet these deadlines. But the bridge will be OPC DA for the foreseeable future. We will likely have more of a robust DA OPC UA for bridge probably a year or two out. So initially the bridge is there to make sure that clients can still gather data via eACM and still plug into their HMIs without having to change a lot of their HMIs. Are there limitations to the number of tagged broker connections that can be obtained through the bridge? The bridge is actually just a repackaged version of the OPC DA server that ACM uses. So it's going to have the same limitations as ACM, which is that there is not a certain number that I know of. So 500,000 plus. It's very robust. How does the licensing structure work with eACM? If we have 300 remote sites, does that mean we have to buy 300 licenses? That is a question I will ask you to please contact me at the following bit of information here. dblanco@autosoln.com. The answer in short is no, it is a little different licensing structure than, for example, ACM, but it is definitely flexible enough to meet everyone's needs who's ever had to use it before. So please feel free to contact me and I'll be happy to answer that. Can the Moxa devices come pre-installed with eACM? My answer to this is going to be yes, and I apologize for the Moxa guys watching now for putting you on the spot. It's my understanding of how Moxa rolls out their devices is you don't buy directly from Moxa, you buy from a certified partner and redistributor of Moxa that generally also sets up things like the SIM cards, the communication to Verizon or AT&T. Depending on whether or not that particular Moxa partner has returned my phone call, then yes, they can install eACM before you get it. So yes, you can receive a Moxa with eACM on it. For example, if you buy from someone like INS out of Dallas. Can AUTOSOL ACM also talk MQTT? Yes, ACM does have a MQTT publisher also scheduled for release. And I think the betas of that go out this November or December. So please contact your local salesman or me for more information on that. But yes, so in January 2021, knock on wood, ACM will have the ability to receive MQTT data, publish MQTT data, and publish OPC UA data. And let's see. Oh, that was the last question. So thank you all for your time. I appreciate those of you that stayed on 11 minutes later. I hope this was worth your time. Again, I'm David Blanco with AUTOSOL. Please contact me at 281-286-6017 or at my email, dblanco@autosoln.com if you have any questions or comments about this presentation. Thank you very much, everybody, and have a nice day. Or comments about this presentation. Thank you very much, everybody, and have a nice day.
Great job. Thank you, David.